Hello everyone, my name is Sophie Wang from University of San Francisco Master of Data Science program. Today I'm going to talk about one of my machine learning projects. Imagine you're a business owner. Your priority is not only know how to acquire a customer, but also how to retain them. Besides trying your best to develop the best product possible, would you ever want to know who is going to leave your business before they actually do so? That way you could proactively find them and take actions to reverse their decisions. In this video, I'm going to walk through the detail of my project, including initial EDA, visualization, feature engineering, model selection, model deployment using Streamlit, and key takeaways. The dataset I have is from Kaggle. It has records of around 10,000 customers of a bank. It has 24 columns for each customer, including their ID, age, education level, income, transaction amount, and so forth. So this attrition flag column indicating existing or churn customer is our target Y column to fit into the supervised machine learning model. So first I did initial EDA to understand the data. From the plot here, it's very obvious that we have a very imbalanced data set, with the churned customer only being 16% of all the customer. And also I plotted the income level distribution and the education level distribution for both churned customer and the existing customer. It looks like that income level and education level doesn't make a difference between the existing customer and the churn customer. So my assumption is that income level, education level are not very important feature to predict. Next is the feature engineering. First and foremost, I dropped the customer ID number because each customer has their unique number and this is not predictive and might hurt the model performance. And the second one is that I impute numeric columns with medium and the categorical column with the most frequent value. Of course, I'd also convert the categorical features from strings to numeric numbers. Everything I mentioned here is done in sklearn pipeline, so I can make sure I apply the same feature engineering steps for both training and testing data. And next is the model selection, which is the most exciting part. Here, I fitted, after splitting the train and test data, I fitted 4 models. There are logistic regression, random forest, extra tree classifier, and gradient boosting. Since we have a very obvious imbalanced data set, I used a weighted F1 score when I use cross-validation in a randomized search. So as you can see that my baseline model logistic regression has the weighted F1 score being 0.665, whereas my gradient boosting, which is my best model, it has the score being 0.91. So of course my winner is gradient boosting. After I select my winner model, I extract the best parameter from the cross-validation process and fit on the testing set. So as you can see that the weighted F1 score on my testing set is 0.91. And also I plotted the confusion matrix on the left and then also the PR curve on the right-hand side. I choose PR curve instead of ROC curve because PR curve is more sensitive to class imbalance situation. Next, I'd also plot the feature importance on the winner model, which is the gradient boosting. So as you can see there, the bottom few features are gender, education level, income category, and so forth, which means those features are not considered important for my gradient boosting model. As you can see, this actually matched my assumption during my EDA process. During my EDA, I said that the education level, income category actually doesn't make a difference to predict whether a customer to churn or not. And this plot just confirmed my initial assumption. Next, after I finished training my model, I deployed it into usage. I employed the gradient boosting model using the Streamlit on the web app. Now I'm going to show you how my web app works. Here's my web page. On the left-hand side, you can see there are all just input features. The ones has drop-down box indicate that there are categorical features with different levels, and the slide bar here indicating that there are numeric features. As we recall from the feature importance plot, the most important feature is the change in transaction account. So let's try that in the slide bar and see what happens. So as you can see there, I changed the slide bar values, and on the right-hand side, the prediction actually changed from churn to not churn. So the good thing about this with website design is that I also include prediction probability here, which also tell you how confident my model is when predict the class 0 or 1. Of course, you're also free to change any other user input, for example, the education level, and also you can change the numbers in your slide bar too. Feel free to play around with it later. All right, so the next last part is the key takeaway. Imbalanced data set is very common in business world, so we need to be careful when choosing the model and metrics. Also, always start from baseline model. Here, I chose linear model, logistic regression as my baseline and see if ensemble models, tree or forest, can actually beat the baseline model. Always lock away your test data sets because we don't want any data leakage, and we want to make sure training and testing have the same distribution. I also chose random forest or random search instead of grid search to improve training speed. Also, for the business implication, check the feature importance of the final model can help you with the business decision making. For example, the bank manager might now care more about the balance or the number of usage instead of the education or income level. But the caveat is, although feature importance is only is interesting, but it's only a hint. Don't treat it as a gospel, since feature importance is very model specific. All right, that's it for my project. And if you want to see more in detail, please check out my GitHub link down below. Thank you.